Okay, so for this video, we're going to talk about congruent segments. So when I say congruent segments, that just means line segments with the same length. Or you can say the same distance. So we can say the length of AB is equal to the length of CD, or we can say AB is congruent to CD. So those both mean the same thing. And we have a special symbol for congruence, and that's this little guy right here. And so what that really is just an equal sign with a little squiggle on top. And that means is congruent to. So the main difference between equal and congruent is that we say lengths are equal. So like the distances are equal, AB equals CD. However, when we're saying congruent, we're just saying the segment in general. Segments are congruent. And so when we're writing that, that's where we need to do our fancy symbol here, where we need to put the AB with the line on top, and then put our congruent symbol in between. So when we use equal, that's talking about the length or distance. When we use congruent, we're saying segments are congruent. And there's a way that we can show that, and that is with these tick marks here. So tick marks show segments are congruent. And really, I should say show which segments are congruent. So this tick mark here, it's one tick mark, and that is showing that AB is congruent to CD. However, we can use more than just one tick mark to show that. So let's say I continued both of these segments. Let's say I have a BE and a DF. And let's say that BE is congruent to DF. However, that it is not congruent to these other two. I couldn't just use one tick mark because then that is saying all four of these segments are congruent. To show another set of segments are congruent, I would need to use more. So I would put two tick marks. So now this figure shows that AB is congruent to CD and BE is congruent to DF because you're going to match the same number of tick marks. And I could continue going. Let's say these are congruent to each other. And it doesn't have to just be two. I could extend this. And now all three of these are congruent. So those tick marks really just show congruence. Okay, let's practice doing one. So this one, I'm going to plot these points. And then I'm going to determine whether JK and LM are congruent. So let's go ahead and first graph JK. So again, when we're plotting a point, remember that this first one is my x's. And the second one is my y. So I need to go on the x-axis first, so -3. So that means I need to go to the left, because remember this is my x and this is my y. So I need to go to the left 3. And then a +4, so I need to go up 4. So that's my j, and I'm going to go ahead and label it as j, so I remember. And then for my k, that's at 2, 4, so I need to go right 2 and up 4. And this is going to be a line segment, so I don't want arrows, I'm just going to put a line between them. Okay, and then let's look at LM. So L is at 1, 3. So that's L. And then M is at 1, -2. So 1, down 2. And I want to see those are congruent. So remember, congruent just means they have the same length. So if I am, let's zoom in here. If I'm looking at this, I want to count the length of it. So I see that this one, JK, has 1, 2, 3, 4, 5. So JK is equal to 5. And LM, when I count that length, that's 1, 2, 3, 4, 5. LM is also equal to 5. So that means they are in fact congruent. So I can say JK, and I put the line on top because now I'm talking about congruence, is congruent to LM. So I say yes. Okay, go ahead and pause the video and try doing this last one on your own. So the answer you should have gotten here was that it is not congruent. So I see when I apply the points for A, B, and CD, the length of AB was 5, where the length of CD was 4. So AB is not equal to CD, and since they're not equal, they can't be congruent. Okay, that's it for this video. Go ahead and move on to the next one to learn about the segment addition postulate.